Hello, Farah, Kelvin, and Noel. All right, so you guys requested that no need to replace last week's practical. I think if everyone agree, that's okay with me. All right, but the practical for last week still need to be done. Okay. So today's practical, we're going to look at last week first, last week practical, which is exploring DNS traffic, right? So DNS stands for domain name service, yeah, right? Recall that DNS is used for resolving domain name to IP address, right? um, because as human being, we are very bad with number values, right? I can't remember um, most of the public IP address out there, right? But we can easily remember domain name, right? Especially with the hierarchical naming convention they use, like for example, the organization name they choose, right? With the high level domain, right? So, for example, google.com or tar.edu.my, for example, right? So those are domain name, right? And this is what we work with the browser when we want to visit a certain web server. But unfortunately, our computer do not like this very imprecise. As you know, the encoding is that we are using binary. So therefore, there must be a way to convert DNS back to IP address, right? That is made of 32-bit for IPv4, right? So DNS traffic is exactly that. So this last week's lab is going to explore that traffic, right? So we're going to look at that. And in this, you might be wondering why the single area or SPF uh, is not covered. We already covered. Once we say we did this configure single area or SPF version 2 already, yeah, and that's the configuration. There are not many configurations. But in terms of theory, yes, there's a lot to support the use of OSPF. But in terms of configuration, the ones that you learn in week 2, configuring single area or SPF version 2, then that's enough already. So as long as you know how to do that, you're fine with SBA. Okay, because multi-area is I don't think we are handling multi-area or SPF. Okay, that's a really large. Think about it, really very large. Computer networks. But in any case, the only difference between single area and multi-area is that the boundary lah, the boundary. So you can create another, if you have single area and then you want to expand your network, create another single area, but then both single area becomes multi-area. So again, there's not much really difference. Okay. Um, to go beyond when you have multi-area and then a boundary between your large network and another large network, then we encroaching into BGP territory in terms of topic. So that's why in week 3 we are exploring DNS traffic instead of continuing with single area or SPF, right? But for this week 4, we do learn how to configure the ACLs that we mentioned in our lectures. Okay, so number standard that means it's standard ACLs, right? Standard ACLs will only filter based on the source IP address, and then we have the numbered versus the name. Okay, so you know that basically if you want it to be self-documenting, instead of using numbered, you want to use name, right? So that one look at the ACL, you know already. Okay, it's meaningful, right? In any case, we are doing that. Okay, we discussed that, and these two are actually packet tracer exercises. Okay, we're going to use packet tracer exercises instead of the typical lab practical. But for now, we start off with the lab. So I'm just going to show here, right? So the thing is, with this explore DNS traffic, because it is meant for the lab, right? The lab environment, the hardware. Okay, so real hardware, we don't have facilities like the simulator mode. Okay, in our packet tracer, usually we in lab we try to do it in simulator, right? Uh, but sorry, in the packet tracer, but we have a built-in simulator that works very well to capture our traffic so that we can debug or understand our our network better, right? But in the real world, we're using hardware, you don't have such facility, so you need to use something called Wireshark. I think in FCN you've already encountered Wireshark before. The thing is, this is an application, a free application that you can download. Okay, it's a networking tool. Okay, so it's a two-edged sword, right? Networking professional or security personnel, people will be using this for good lah, right? You can use this for troubleshooting, find out what's going on with your network. If you're in security, you want to see whether there's any anomaly in the packets flowing through your network, right? And you want to find out what's happening. But on the other hand, in the hands of a hacker, black hat hacker, they can use this to eavesdrop as well. If your traffic is not encrypted, they can use this. Okay, in a real network, how does it work? Wireshark. Okay, just a recap. Wireshark is a driver for your NIC. Basically, it takes over. When you run Wireshark, it uses a different stack than your built-in OS, because your built-in OS works in a standard mode, which means it will only accept or take in packets that is meant for your IP address, or in the LAN, frames meant for your MAC address. Okay, so it will. What happens to those other packets that's flowing in? Well, it's just discarded. It's dropped. Whereas Wireshark is working in a promiscuous mode, which means it doesn't check. So that means when you run Wireshark, it will run its own driver, okay? Instead of the usual OS-based stack, it will use its own stack. That's why you will see that it will install a network driver, right? And this network driver works in promiscuous mode, means it does not care. It's just taking whatever frame that it reach the NIC, it will take in. And you can capture, simply means you get the frame, you save it, right? Save it into your secondary storage. So all the frames coming in, if you capture, if you match the filter, then it will store in a file, right? In a file. So then you have the capability, just like packet tracer, to be able to go back and check all the captured frames. When I say frame, just simply because I'm talking in terms of LAN, but of course you can capture the whole PDUs, right? All the way to application, right? So you can then, like in a packet tracer, you can view at any layer. You can view at Ethernet layer, you can view at network layer, you can view at transport layer, you can view at application layer, right? That's why I said it's very, very powerful. You can use it as a network administrator or a computer security expert. You can use it for good, or as a black hat hacker, you can use it also to eavesdrop and maybe plan your attack, right? So Wireshark is you can download, and in fact you can download and start using it, right? So here I will just describe this because we are not you can do this and check DNS traffic from your own computer. All right, but that means the DNS traffic that you're going to see is actually a DNS traffic that is based on your ISP. So by default, if you subscribe to Telecom will have their own DNS server, and you can put in their. I mean, because you are on DHCP basically. When your modem connects to the ISP will provide all the uh, public IP address and everything else, including DNS. So by default, if you connect to your ISP, your DNS will be the DNS server of your ISP, right? Okay, so when you're exploring the DNS traffic, that means the DNS request and reply is between you and your ISP DNS server. Now, one thing that most people will not know, but you guys, because you guys learning networking, you would already know, is that you can always change your DNS server, right? You can change at the source, at your router, right? Or you can change per device. In fact, if you're, especially if you're using Windows 11, Windows 11 very easy. You can just go right click on, if let's say you're using Wi-Fi, right? Right click and configure your Wi-Fi. There is a part where you can actually put in your own DNS server. So what you can use Open DNS, you can use the one or encrypted one, the one Cloudflare. You can use Google. The good thing is none of these servers are censored, which means and we are not talking only about porn, yeah, censored in terms of porn, but sometimes certain website, which is actually if the government deem that it's not suitable to be viewed by you, the MCMC will instruct the ISP, okay, in your DNS server, block this domain name, right? So that means if you're using their DNS, because their DNS, they already block that domain name, whenever you request for that IP address, that you will not get, right? So if you use one of those open DNS out there, which is also maybe faster, because, well, they are big companies, right? And also maybe encrypted. I think Cloudflare has some encrypted. I'm not sure whether you have to pay, but I think it's free also. Then they do not censor, right? Okay. So yes, so that's the one that you can configure per device or per router in your home, right? So if you want to test out, you go through this, right? But of course, we don't have our own hardware. So basically, you will test the DNS traffic that is between your computer or your device versus the DNS that you have set up. Okay. That's why I said by default, it will be to ISP. But if you change your DNS server, then it will be going to other DNS server that is not censored. So let me just give you an example. The easiest example is Google DNS. Any of you, sorry, any of you ever tried to change your DNS?
Yeah.
Yeah.
Yes.
Yes. So this is one. Google Public and Open DNS is another one, right? And I think Cloudflare. You try to find the one that is the fastest available that is free, and also if it's secure, right? So I think Cloudflare. Right. Yeah. I think yeah, that's the one. I think yeah. I think it's, where did I get the last time? I think here. I sometimes put my primary to one DNS server and my secondary to another DNS server, just in case, the primary belongs to one company, right? And it's go down. The secondary doesn't go down as well. It goes to a different company, right? So there are a lot of there. Go with the big ones, right? The big ones. Now I'm not sure Google really tracks you or not, or not. But as usual, if you're not sure, assume that you're being tracked, right? All right, so let me see. Open DNS. Encrypted because well, the DNS server will know, but the man-in-the-middle attack, right, will not be able to see where you're going. I mean, what you're checking, because they can see what website you're visiting by looking at your DNS requests, right? But if you want to stop man-in-the-middle attack, you encrypt it, right? So that's why we have this DNS encryption, lah, right? Okay, so back to our here, capture DNS traffic. Use the download Wireshark. I think just like Wireshark on in Google, you can see the website ready. You can download. Right now, make sure to make this work because by default your browser or your OS will use its cache, right? DNS cache because DNS cache fast. Just take from the cache rather than going to the DNS server, which takes time, right? So make sure you flush it out or clean it first by doing in the command prompt ipconfig flush DNS. This will empty or reset your DNS cache. And so the next request, because it says it tries to get from the cache is empty, so it doesn't know what is the IP address, then your OS will initiate, okay? Initiate to get the to resolve using the DNS server that you entered, right? So to make sure that it works, that you can capture some DNS traffic, flush your DNS first, right? Okay. And then you can use if you don't want to use the browser and you don't want to use the browser and then the browser initiate the DNS call, you can use another tool or software called NS Lookup. Okay, so NS is the name server, so it's the same thing. So you say NS Lookup, and then you type in the domain name that you want to check what's the IP address, right? Okay, but it's also give you additional info, lah, right? Okay, so when you do NS lookup, you should, when you capture, you filter to DNS support, so that it doesn't capture everything and you end up with a lot of just to capture the DNS traffic inside your Wireshark. Then you can then check. Once you do this NS lookup, you can see that you start capturing DNS traffic, right? So part of the traffic is the query. Query is from you querying the DNS server, right? And here you can see some description about how to view that traffic. Okay. Right, and then and so on. Yeah, here ARP basically is checking your MAC cache, MAC address table cache. This is your own, because if you want to send locally, you don't have the you don't have in the cache your own cache, the physical address or MAC address. Then you have to use ARP, right? ARP to get the physical address, the MAC address, right? But ARP-A will show you the content of the cache, right? All right. So, okay. So again, just go through and follow exploring. This is DNS, right? Okay. This in this exercise, you're basically exploring the DNS traffic, but it's not really only for DNS. You can capture and explore or analyze any traffic with any protocol. Okay, it's up to you. But here, the example, so that you get to know, is DNS traffic. Once you know how to go through but the DNS traffic, then you can try other traffic, HTTP, FTP, or whatever, right? Okay, so I think that's it. This is interesting. This is fun. This part, right? Just the only thing you need to do is to download the Wireshark, lah, right? Okay. Any question on this last week's lab practical? Farah?
So far no.
No, huh? Well, you can try it, huh? Kelvin and Noel.
Is this the only practical for last
Yeah,
week?
this is the lab, right? But of course, for the weekly exercise homework, you have this lah. Okay, continuation of the OSPF. You can see there, the first exercise for your home, okay, is propagating default route in OSPF version 2. Second one is verifying single area OSPF version 2. These are all packet tracer exercise. Single area OSPF configuration, right? It's a continuation of the lab that you've done before that in week, I think week 2, yeah, configuring single area OSPF version 2, right? So a continuation of that is homework here. Okay, also from here you go to here. All right. Okay. Is that okay, Noah?
Okay.
Kelvin?
Okay.
Okay. All right. So in that case, we move on to this week's practical, which is these two labs. Okay, also available here. These two packet tracer. Yeah. And there are, if you can check here, is to configure numbered standard IP version 4 ACLs and configure name standard IP version 4 ACLs. And let me just go to the exercises. Is also packet tracer. This is homework, yeah, ACL demonstration and configuring and modifying standard IP version 4 ACL. So it's just more of the same to get you to, to practice on the ACL. All right, so download the packet tracer. We'll start with the 5.1.8, all right, so that you can open up that packet tracer activity file and then can do it. Yeah? All right, so I'm opening up mine. Okay, so here is here's the topology. Let's whenever I look at activity files, I look at topology first to understand what device I have, what I'm looking at. So this is standard SCL. Standard SCL look at the source IP address, right? And what was the best practice for standard SCL? Should we put, okay, I'll open this question to 3 of you. Should we put it near the source of the traffic or near the destination? Anyone? For standard ACL, what's the best practice? Should we put the ACL
Destination.
the source or destination?
Destination.
Destination. So depending on where the destination are, right? If we say from here, this is our source, the destination should be here, right? But the thing is, it can go here. So then you have to make decision like what we see in lecture slides. Should we put there? Okay, since we have two paths, right? And here we are not concerned, well, although we learned already of OSPF, right? So which path it will take based on the whatever speed and such for the shortest path, right? But here, if you don't want to bother about that, since we only have one here, which one is better? Here, or this interface? You can see, you have to make the decision. If you say destination, there are three interface here on R3, right? If this is the destination, depending again on your policy, usually when you set ACL, you will be given a policy in words, in sentence. Please block or allow this please permit or deny or block or allow traffic from so and so subnet to so and so subnet or so and so host, something like that. That is a policy. Then you have to convert that policy meaningfully into an ACL. Always remembering when you use ACL, at the bottom there is a deny all by default, right? So you have to be aware when you are permitting or denying. But if usually it's permitting, then you deny, right? So that means you permit a certain number of or whatever, and then the rest you deny. Okay? Because default is deny at the bottom. So if you want to, so that means you check, right? What range you want to permit. The second thing you have to check about is the wildcard mask. Okay, shortcut 255.255.255.255 minus the subnet mask of the IP address in question, the one you want to match, and you get the wildcard mask. Right? So you sort that out first. Okay, the wildcard mask. Once you sort that one, that means you there's a matching possibility. Then you check whether it's for permit or deny. All right. So let's have a look at the here. Right. You're given the addressing table, 3 routers, 3 hosts, and the web server at the site. So let me just put it like this, so easy to see, right? Okay, so there you have the 3 hosts and the server here, web server, and the 3 routers. Okay, there's no switch configuration. That means we're not concerned about switches configuration in this exercise, right? Okay, so plan an ACL implementation. So you finish planning, you get the ACL plans. Basically, is you take, like make notes first, right? If you create your ACL in your notepad or you write down. I think in notepad is better, so you can copy paste later. Don't straight away go there, type. You have to use a notepad, for example, write out your ACL list and make sure when you look at it, okay, it makes sense. You try to walk through like what you do in programming, code walkthrough. Here, ACL walkthrough. Start from the top and then go in sequence. Be a robot, follow exactly. See whether at the end, or possibility that you actually satisfy the policy given to you, right? And then once you are satisfied, then only you go into whichever router, whichever interface of the router to configure, apply, and then verify your ACL, right? All right, so before applying any ACL to the network, it's important to confirm you have full connectivity. Make sure, means ACL, usually if in SBA you have ACL configuration, do not set ACL first. ACL should be one of the last step, because if anything wrong in your configuration, right, and you put ACL, you don't know whether it's your configuration or the ACL that is problematic. If you make sure that your network is correct first, then if you enter your ACL and something, that means your ping doesn't work, you can confirm that it's not because of any other network error. It is the ACL got problem. Remember, that's why it says here, it means before applying ACL in the network, it's important to confirm your full connectivity. So I'm talking about SBA or even in the real world. If you have not confirmed your network is correct, there is no error in configuration, right? And you put ACL, then if something is wrong, how do you know it's ACL or configuration? Then you put yourself in a very difficult situation, right? So in SBA or in the real world, if you configure, you test everything works, you're confident already. Then you apply your ACL. So if there's anything wrong, that means cannot ping or whatever, then you know it's the ACL. So then you fix the ACL. All right. So that's a tip, yeah. Then step 2, evaluate 2 network policies and plan implementation, plan ACL implementation, right? So this is the network policies that you have to convert to ACL, okay? Okay, this is what I'm talking about. You need to know what is your policy before you know what SCL info you want to apply on. Okay, right. So it says this network, this subnet. Where's that? 11. This one, right? 11. Here, this network subnet. Not allowed access to web server on the this. So this web server lah, not allowed. So where do you put the filter, the SCL? Is it here? Is it here? Is it here? You filter here, then you don't allow traffic from here to use this path. Yes, you have another path, but then maybe you want to have another path just in case this one go down, you can, right? Without change SCL. So here and here will block this path for this. If you block that, because it's standard, that means all protocols. So what do you think? Here, right? If you block here, yes, it process first, but at least this part is open for this network. Right? Any question there? Since we say the destination, so standard is try to put the ACL at destination, nearest to the destination. Is it okay? Farah, Kelvin, and Noel?
Okay.
Right? You understood the why, yeah?
Okay.
Because there's a consideration that, oh yeah, if you block there, it needs to be processed first. But it's okay. If we want this path, right? Maybe it's not to go there. Maybe it's going to here, right? So if we block here, then cannot already, right? So we block here, no choice, process lah, right? Introduce latency lah, but that's the best. Okay. So just follow the network policies given, right? And design the ACL. When you're designing ACL, it says not allowed means deny, right? But you allow others. So how do you create the ACL? We know at the bottom is deny all by default. So do you deny this? So that means your wildcard is 000-255, and then allow all traffic. If you say allow all traffic, the built-in deny will not be run. Why? Because all, that means all the traffic already catered for, so it will not drop down to the default one. You guys understood this part? Yeah.
Yeah.
Yeah. Once the ACL processing see that all traffic has been catered for, it will not drop down further. If there's any other ACLs, even the built-in one, the deny all one. So you block this one, which means deny this and the wildcard 000.255. You ignore that part here, but you say match all these three. That means this particular subnet will be blocked. Deny, right? And then allow all, any. This one already denied. Then that means allow any will be the rest, but it will then stop there. It will not use the last built-in one. All right. Okay, so you design, this is how you design. You find out what is the policy, design your SCL, make sure it works, identify where you want to put the SCL and place it there. Right, the second one is here. This one I let you try. Okay, based on this policy, what is the ACL, where should you put it? Okay, right. So here, the part 2 is where you actually configure it, right? You can see step 2. Then step 3 is verifying. See whether it really does. When you try to do some traffic, see whether this policy is actually followed correct, right? So that's your activity for this one. Let's have a look at the second one. 519, configure name standard IP version 4 ACLs. Okay, for that one is here. So the topology is a little bit different. Okay, you have one router, 4 switches, 3 hosts, two servers, web server and file server given here. And objective in this second packet tracer is configure, apply a name standard ACL and verify your ACL implementation. Right. So first of all, I can see that all green, right? The Dns traffic is flowing free, but just check first lah. See whether PC1 can ping, PC0, all this lah. Ping, 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 ping. Make sure you verify all connectivity okay before you go to step 2, right? Then we configure name standard ACL, right? Just follow, okay? Right, so the scoring here means the score here lah. Where is it? When you check, let's see, not here. Here, this scoring, this completion rate. You see that the bottom right hand corner, that's scoring. So says ACL name is case sensitive. So if you want to put this, right? So please follow this exactly. This mixed case, right? Uppercase, lowercase, and all this must be exactly so that because the comparison for scoring is very sensitive, case sensitive, right? So you want to get it correct, right? Just follow the steps. Apply the name API ACL, sorry, right? Save your configuration, and then verify it. This one is short. Basically, just follow. Now, again, if you see your completion rate is not moving, it could be the you have a typo, or your casing is not correct lah, because it's very it's case sensitive, right? Okay. Right. Any question?
No.
No. All right. So it's okay. You can proceed. If you want, you can do the last week ones first, or you want to proceed to this week's practical. It's also okay. Right. So I will be monitoring our Meet chat here. If you have any question, let me know. Is that okay, everyone?
Okay.
Okay. All right.